Hello and welcome everyone to the fourth tutorial of the symposium. I'm happy to start sharing my screen when you're ready.
Yeah.
Right. So
Are you sure now?
so let me know if this screen can be viewed. All right. Great.
Perfectly well.
All right. Sure. Thank you. All right. So thank you very much for the introduction. I have a slide on a short bio of myself, but I'll probably skip this thing, given the introduction. I So we have a session that's planned for about 50 minutes, and then we'll have questions towards the end. So during those 50 minutes, I'll walk you through how Power BI can be used in various stages of data analysis. Now, I also have a live demonstration of a Power BI based web application. I would love to take your questions, but I think in the interest of time, we might want to park the questions towards the last 10 minutes of the session. And if we are running ahead of time, I'm happy to take the questions in between also, no problem. All right. So we start with a brief introduction about Power BI and its status in the market. I mean, Power BI is being considered as one of the hottest of the low code or no code business platforms. And there are quite a few reasons why it is. So, and what I have shared in here is Gartner's 2025 Magic Quadrant Analysis report on the BI vendors. Then you can see right in here that Microsoft's Power BI platform is considered the leader of the pack. Now there is a link in the slide. Feel free to read the blog. It gives you certain details on why. On unique selling proposition of Microsoft Power BI. Pretty sure all of us in here are pretty much well read and acquainted with it as well. So moving on to the next one. See now, in my opinion, Power BI is just not a standalone application. The reason why it's become quite well accepted is because it is actually a suite of applications. There is the Power BI desktop, which is where you actually turn data into actionable insights, and then you have the Power BI service, which is the software as a service model there. So that's where users share and share the content, and then the end users can consume and interact with the content. So, in my opinion, if you get this right, about 80% of an enterprise's reporting needs can be met by leveraging just these two, the Power BI desktop application and the Power BI service. Now, there could be a few specialized needs like the need to report with a need for a print version of the report in addition to the online version of the dashboard. So in such cases, you would probably need the use of the Power BI report builder as well. On a few occasions, an enterprise might say, you know what, my reporting cannot be published on the web. It needs to be on-premise based. So that's where you probably need to use the Power BI report server. Now, likewise, there is the mobile authoring layout in the Power BI desktop. I'm happy to show that during a demonstration. But in case you want to leverage that piece, you would also need a companion Power BI mobile application so that you can display these mobile-friendly versions of the report. Now, in this tutorial, we are going to focus largely around the Power BI desktop and a little bit on Power BI service, but the rest of it are out of scope. So moving on, we talked about how we would see Power BI can be used on different stages of data analysis. Let's start with the first one, which is ingesting data. Now, any reporting ask would begin with importing the data from a data source, and Power BI has about 500 plus data connectors, which can easily be configured with the appropriate connection strings. In fact, in Power BI, when you launch a desktop and when you click Get Data, it throws up a dialog box which shows these data connectors. In fact, all grouped, largely grouped into 5 categories there. I've showed the screenshot where you click Get Data, it pulls up this dialog box where it's grouped by file. File is a group of all the commonly used data connectors. And the most prevalent of data sources are Excel sheet, the CSV file, the text file, the JSON files, or you might want to get data at bulk from a folder. So those kind of data connectors are available in the file grouping. Or you might want to extract from PDF or SharePoint folder. So the most commonly used data connectors are in the file folder. Then there is this database folder where if you want to extract data from a SQL database or an Oracle or MySQL or PostgreSQL, any of the most of the commercially relevant databases, you would find data connectors. You ask it, you name it, it should be there in the database folder. And then off late, Microsoft has been promoting the Microsoft Fabric and the Dataverse, the Power Platform data connectors. Fabric is to help you connect with the Fabric data lake, while Power Platform data connectors is to connect with the Dataverse. The legacy version was the common data service. Likewise, you have a few connectors Azure related. If you want to connect with Azure Azure SQL or even the non-relational DB, Azure Cosmos. And then of course you have a few of them online services, like if you want to extract data from Google Analytics or Adobe Analytics. So you probably get the gist. I mean, there are quite a few data connectors already there. It's for most of the data sources. In fact, I have provided a link to all the data connectors, which are currently there in Power Query. In the next slide, I have shared a snapshot, just a snapshot, of the data connectors and which service you can connect to using these data connectors. The check mark in there says the data connectors are applicable for that service, while the X mark says it cannot be applied, it cannot be used for that particular. It's not supported in that listed service. So, um, so this is probably the one of the hardest instance because when we want to gather data, the first thing that we are stuck with is about writing APIs or using the right libraries, and then we need to configure with the right permission settings, etc. So most of that is taken care of, made very useful, made very friendly using the already created data connectors. So like what I said, so upon choosing the appropriate data connector for the data source, you will also need to configure. But the configuration, I'll show it in the demonstration. The configuration for example, the SQL Server connector is pretty intuitive. So you will need to specify these configuration parameters, and that's when the entire data connection string would be established. So moving on, right? So that's the first step. So now you have ingested the data from any of the from multiple data sources. So what do you do with this data that is ingested? Now you would need to now shape the data based on you need to shape that, transform that to a data set, a specific data set which is relevant for your analysis, right? And so how would you do that in Power BI or even in Microsoft Excel? The current versions of Microsoft Excel comes pre-packaged with something called Power Query. And in the previous slide, I showed the various connectors, data connectors that are available in Power Query. So right now I'm going to show how you can use Power Query to transform the data. So in Excel, you'd find the query tab at the top. And you click the query tab, and then you can access the query editor. While in Power BI, if you're importing the data for the first time, you have to go through. You click Get Data and then follow the prompts to get to reach the Power Query editor. If you have already imported the data, you could access it directly using transform data. So I'll walk you through all of this. When you see the visual, the demonstration, it's going to become a lot more simpler and easier. So you click get data, you access the appropriate data table. So it prompts you to access the data tables available in that particular data source, and then then it launches the Power Query editor. It's a menu-driven interface, a snapshot of which is what I've shown in here, the Power Query editor window. So if you take a look at this Power Query editor window, just as with any Microsoft product, I mean, it's pretty intuitive. The interface itself is pretty intuitive, and there's a lot that you can achieve in terms of data transformation just by the menu-driven interface. On a few occasions, you cannot. You might have to write a code, and then I'll show you how to do that. But I would say about 80 to 90% of all the data transformations that you need, you can actually use the menu drop downs and achieve that as well. So let's start with what is marked as number one there. So that is the query ribbon. And in that query ribbon, you would find a lot of the data transformation tasks grouped under 4 tabs. There's the home tab, then there's this transform tab, there's the add column tab, and there's a view tab. The transform tab is probably where you would spend a lot of your time with. So you start with most of the basic functions on data transformations, like adding, removing columns, changing the data types of columns, splitting columns. All of that can be addressed from this particular tab. Then there is the add column tab, where you would go into nuances, for example, changing the formatting the column data types, adding custom columns, and all of that can be achieved using the add column tab. Then there's a view tab. So this is the tab where you would probably you could use it for multiple purposes, for toggling display screens, etc. But also primarily you would use it for accessing the advanced editor. That is where you would probably write your own code in using a native language of Power Query, which is called mashup, or M language in short. You would use that Power Query language to write your own code. Then, so you would notice number 2 is the queries pane. So when you write any of the queries, all the queries in your data model, they're listed in here. And when you click any of these queries, the data that is extracted by the query is listed in the central pane, which is number 3. So the central pane is perhaps where you would spend much of your time, a lot of your time, in terms of writing all the transformations, etc. So starting with the columns, if you see at the top, the column headers, each of the column headers would have a small drop down. If you click that drop down, all the transformation tasks relevant for that column data type will be listed. So you could choose that transformation activity, that transformation task, and then when you select that, it gets applied. Now, when those transformation tasks are applied, those tasks are also recorded. They're recorded automatically, and they get listed in the applied steps, which is in number 4, the pane number 4, which is query settings, applied steps. So you would find them all listed sequentially, as and when you apply the transformation steps or transformation tasks. Now, this sequential representation is pretty easy. Oh, oops, let me just go back. So the sequential representation is useful because if you want to undo some of the steps, it's as simple as just clicking the X mark there. It undoes the step. So in a way, you can think about this as it remembers what you did, and then when you click refresh, it just executes that. It is automating your transformation activities by through a menu-driven interface. So I think, yeah, that's all that I probably wanted to talk through in here. Yeah, and then the advanced editor tabs. So advanced editor, see, when you could achieve most of what you want to do using these menus, but then, like what I had said, once you get more proficient with Power Query, you might want to start writing your own code using the native language, which is Power Mashup. The link to which I've given in here, you could right click that and then go through the syntax guide to understand this language a lot more deeper. It's pretty easy. It's very, very intuitive. It's like writing an Excel function, actually. So so you would probably start using the advanced editor a lot more, because then what you can actually join multiple transformations in one statement. So rather than having each listed down step by step, which just which elongates your transformation steps. You could join multiple steps together using this code, so it makes it more efficient. As you get once you get more proficient with this Power Query, you would probably start using this. So that's with shaping data using the Power Query menu-driven interface. Now, after you have injected the data, after you have shaped the data, you need to model it, so that you can draw some kind of insights, inferences from it. So that's the next step. Now, in my opinion, the modeling and the shaping of data, it's an iterative process, because you probably it's not a waterfall model. You'll probably end up going back, shaping the data, remodeling it based on the stakeholder requirements. And then I look at modeling as two distinct phases. There is a semantic modeling phase, and then there's a data modeling phase. Right? So a semantic model is where you're actually looking at the data and organizing it in multiple tables, and then building relationship between the tables, and adding aggregations or calculations within the tables. So all of that is stored within the data model. Now, for semantic modeling, there are three methods in which you can load the data into your semantic model. The first mode is the import mode, which is what I have illustrated in this figure in here. So, as you would notice in this figure, that in the import mode, you're actually taking all the data and loading the data into Power BI memory. So, which means as your data in the data source grows, your Power BI data model also grows. But then the best part is the Power BI applies a patented compression algorithm. It's Vertipack algorithm. So what Power BI does is, by the application of this compression algorithm, it achieves about 10x compression from when you compare that with the actual data source. So that's one advantage. And second, the way Power BI stores the data is also different. In a sense, it stores it as a column in our database. So when you have something stored as a column in a database, it becomes easier to aggregate column wise. So which means it speeds up the performance of a query. So those are the advantages of using an import mode, where data is loaded into memory. It gives you the best query performance. So having said that, so then if that gives you the best query performance, why would you not want to use it every time? That could be your question. So the reason you won't use that every time is there could be certain scenarios, like, for example, when you have very, very large data sets, the sort of data sets where you would start running machine learning algorithms on, or when you want real-time analysis, real-time data analytics, then you would need to you will need to connect to the data source directly. So that is where you would use a second type of mode called the direct query mode. So that's in the next slide. So as you see in this figure, in a direct query mode, you're not importing the data. You're establishing a live connection with the data source, which negates the need for loading the data into your model. Some of the other advantages are, besides your model being light, sometimes organizations can have certain data governance management restrictions, guidelines, saying data cannot reside in data needs to reside in particular geos, etc. So in order to comply with those guidelines, you may end up being mandated to use the direct query mode. And also typically, you would use direct query mode on fact tables. So the fact tables are tables which tend to hold large volumes of observations. Right? But then you also have to note that in the direct query mode, some of the DAX measures will not work. They're not compatible. So realistically, as a data modeler, you would end up with a combination of both. An import mode, tables built in import mode, and tables built in a direct query mode. That is called the composite mode. So that's in the next slide. Right. So as the figure illustrates, and as the name also suggests, you would have a few in this particular mode. You would have a few tables in the import mode, and a few tables in the direct query mode. So generally, the dimensions are in the import mode, and the fact tables and also the quickly changing dimensions, they are in the direct query mode. Now, there's a lot that one could talk through in terms of semantic modeling, but I think in the interest of time, I provided a link in here. In the previous slide, you could look at the link. There's very good reference material given in the MSDN library on these types of models, the pluses and minuses, etc. So you'll also notice that I've actually sneaked in a few terms, and I talked about facts and dimensions, etc. So let's explore that further. That's the next concept of modeling. So let's explore that further. Now so we talked about semantic modeling. The second concept that I want to bring about in modeling is the data modeling piece, right? Now in data modeling, essentially, what is a data model? It's nothing but a relational model, right? Now off late, the most popular schema of the relational model has been the star schema. And why has it become more popular? It has become popular because of the prevalence of the analysis service platforms, so like Power BI, etc., where the emphasis is on speed of query performance. So that as a result, star schema has actually exploded in popularity and preference. Now, it is called a star schema because essentially you have a fact table in the center, and then you have all the dimension tables in the periphery. So it looks like a star. So in this example, you have sales, all the sales recorded in a table, and then you might want to aggregate sales by a product, or aggregate sales by reseller, employee, sales territory. You want to know what are the average sales or total sales by each of these. Or you may want to know what's the total sales or month-on-month sales for a specific duration. So the date is a dimension table. The rest of it are dimensions, and you have the aggregated sales in a sales table. So you could say dimensions are factors by which you want to slice and dice the data. And then each of these factors you would see that would have its own levels. So the levels are called the granularity of that data. So for example, your date, you might want to slice the data by month, by quarter, by year, by a combination of both. Likewise, employees, there could be many employees by each of the employee IDs, etc. So these are various levels, the granularity of the data. So when you talk about granularity and cardinalization, that's a third important concept of modeling, that is normalization and denormalization of data. And so let's discuss that in the next slide. So essentially, what is normalization? What is denormalization? If you look at it from a high level, it is nothing but you're talking about atomicity of data. How repetitive is your data in your database? Now, unlike the OLTP, the transaction processing databases, the e-commerce databases, where data is strictly not allowed to be duplicated, so that you preserve the referential integrity. In all app databases, the analysis server databases, they by design, you're sacrificing this atomicity for speed. Therefore, the end result is the OLTP databases are generally normalized. They are 1NF form, but then the OLAP databases are generally 2NF or 3NF, which is denormalized data. So which is what is being shown in this figure. So in the denormalized table, for example, you will see the product key, but along with the product key, you will also find certain descriptors of a product. You would find a product name, category, color, size. So you might want to ask why. Why do you want to replicate that in this particular table? Because you're very likely to have another table called product, which has the same information. But you might want to, because essentially in a totally normalized table, you would have to write a lot of data joins, and the more the number of joins, the slower the performance of the query. Therefore, it's a balance as a data modeler. As a data modeler, you need to think about how much to normalize, how much to denormalize your table, and it's part science, part art. So in fact, when we get the data extracts from a database, it's largely denormalized tables, just like this. It's we often call it a kitchen sink because it has all the columns in there. It's up to you to model the data. So as a data modeler, one of your key responsibilities would be how to convert these denormalized tables into normalized ones, and how to define a relationship between the normalized, denormalized tables. So that's the next concept of relationship. What's a modeling relationship? So in the next slide, so in this particular slide, I'm showing at a very high level. See, a model relationship is essentially how you would connect the various denormalized tables, and how the filters would propagate. So for example, in this figure, you have a sales table at the center. And then you might want sales by the state. So a state is a dimension which is in one particular table. So for you in a country, you have one state, right? So that's the relationship between that state and sales is 1:many. So largely the model relationship, there's 1:1 relationship, there's 1:many, or many:1, and then many:many. So that's nothing but how many records do you have for that key. So it's a cardinality of the table, right? So in here in the figure, you're saying if you in the figure here, if you want to aggregate sales by state, it is possible. For every state, you can find the total sales number, or for every product, you can have the total sales number. So that is a 1:many relationship between a product table and a sales table. Likewise, for every date or a sequence of dates, between the date table and the sales and the sales facts table, it's generally a 1:many relationship. You would also notice the state is extended. So there is because of the filter propagation, the way it's designed, you will also be able to aggregate. Though there's no direct relationship between sales and region, you will still be able to aggregate sales and region because of the way the filter propagates. If they say, I want to know all the sales in the northeastern region of a country, then the way you have designed the table here, so northeastern region will have many states, and all those states will the sales of all those states are aggregated. So that's how the filter propagates. Now, it is possible to tweak the way this filter propagates, the direction of flow. Now, how would you do that? You would do that by writing certain DAX expressions. So that's the next and probably the final concept of data modeling, with which I would stop. So DAX stands for data analysis and expressions. Right now, it is very, very similar to writing Excel functions, which is why it has grown in popularity also, because the learning curve required to write a DAX measure, they call it measure in Power BI, is not it's not too great. Now, if you're well equipped in writing Excel functions, you should be able to pick it up pretty quickly. So a measure, think about a measure as nothing but an Excel formula, but that Excel formula can adapt based on the implicit context, which is the way the filters propagate, and the explicit context, which is the filter chosen by the user. So you can also modify the way the cross filtering works. That is, if you want to change the direction explicitly, you can use some of the DAX functions that I have listed in here. They are just a few of the DAX functions. In fact, you will probably need about a day or at least a couple of days of workshop to understand DAX, the DAX functions in its totality. But we don't have that much of time, so which is why I have provided the link to the DAX reference guide here. It's the native language of Power BI, and though it appears simple, the complexity is in the context transition. So sometimes what happens is, though you write the DAX expression a certain way, you would not see the result. And that's because of the way the transition has happened, and you don't realize the transition happened in a particular way. So that's where it's part art and part science, and that's where you need to practice in writing the DAX expressions. So with this, I would probably stop here and give it a break, because I think so it's about half an hour. We might need some more time to look at the visualizations, but let me probably see if there are any questions. If there are any questions, I'm happy to take the questions. If not, then I'll just I'll proceed to the demonstration.
Yes, you can proceed. Yeah.
Okay. All right. So So let's so as of now, what is it that we have seen? So we have seen some of the theoretical concepts of ingesting data. We've seen some of the theoretical concepts of shaping data as well as modeling the data. I will now bring up the Power BI desktop file, which was. Let me just give you the case context in the first place. So that's in the next slide. So for this demonstration, I'm going to pick up a case study. This case study is about how Power BI was used to ingest, shape, and model the data for a charity organization. Right? Now, all credit due to an organization which is the Operation Research Society. It's a society where I volunteer, where I volunteered for this project. They do a fantastic job in being an advocate for the OR discipline. So essentially, they have a platform where volunteers can volunteer their time and effort in applying OR for helping charity organizations. The data comes from an organization called Charity Excellence. So a lot of credit for that leadership as well, for their vision and steer throughout the project. The project was about reviewing their data infrastructure and then creating a real-time analytics portal. Because they felt the need for that to gather better insights from the assessments being submitted by the various charity organizations who are members of their platform. So that was the problem statement, and then so they already had. In fact, they were pretty advanced. They already had a SQL data store with data from close to from quite a few charity organizations. Each of them were asked to submit a questionnaire based which covered their operations, and they did that every year. So they had close to about 500 statements on most of their activities, based on which the organization was able to correctly predict the outcome of COVID, as well as on the charity sector. They were also able to correctly predict the outcome of cost of living crisis in the UK. So they were already pretty good. But then what was the problem? They're so good, then what is the problem? What is it that we're trying to address? So the mandate given was, you see, they built a good model in SQL Server, which could provide accurate forecasts, but then they could not scale that model. Right. So the proposal was to leverage all the data that was in this SQL data store, right, by creating a set of Power Platform components. So there were a set of components that were used. We're only going to demonstrate the Power BI piece, right? Just this piece for this demonstration. And what we're going to see is how was Power BI used to get this data from SQL, how was it transformed, and how was it visualized later. So with that, I'll toggle to the Power BI desktop. All right, so it's visible. So this is the Power BI desktop. I think I minimize this. All right, yeah. So see, in a Power BI desktop, let me start with the basics. So when you create any model in Power BI and when you save that Power BI model in your desktop, it is saved with an extension called .pbix, right? So which you can open using Power BI desktop, which is free to download as well. And when you open that file, essentially it pulls up a menu-driven interface, very easy, just as with any Microsoft product. You can navigate the menu. It won't take you long to figure the menu directions. Now, in here, when you log in for the first time, you probably will not see anything in the pane. So you would start with get data to get the data from the various data sources. Right now, I have injected the data from the SQL table. Therefore, you see in the data pane all the data tables that have been which have been queried for. And how did I query that? So in transform data, I've put in the data under data source settings. So first I chose the SQL data connector, and then in the data source settings, I specify the connection string. So this is not the right string, and I've scrambled it. So which is why it will not connect now. So essentially, this data connect, this window that you see is specific to a data connector you choose. So let us say you choose an Excel data connector, you will not see the screen. So this is for the SQL Server data connection, where you specify the IP, the database name, the permission levels, the encryption levels, etc. Once you do that, you will be able to connect to the SQL data store, and you will be able to extract the data. So all the data resides in the data pane. So you will notice in here that some of all the tables that are there already in the SQL data store, it is present, it is shown as with a particular icon, in the table icon. But there are certain tables that I wrote, that I dynamically created based on the data that is loaded. So those kind of tables you will see with a calculator icon. So that's the calculator table based on the data that exists in the data store. So these were the measures that were written to create a homogeneous date, because that is important for you to plot. A homogeneous date table is required to plot time series data. So that you will also see certain measures that were written. So how do you get the count, etc., based on a filter? So you need to write measures. Those measures are listed in a file, in a folder here. And if you click each of these are the DAX measures based on the context that were written for this particular data. You can also, now this is the report view. You could also look at the DAX view, just in case later you have a lot of DAX measures written. You want to quickly look at what are all the DAX measures written. The DAX view gives you the list of all the DAX measures. Now, in case you want to take a look at the data that is loaded, you toggle to the table view. So in the table, for example, in all the data, you click the table view, and then you click the table. It shows the data is loaded. So this is for you just to quickly check is everything being loaded right. So then you can quickly move to the table view. The relationships. Now this is a relationships you define based on the tables that you have created. So in the you'd see the various data modeling semantic models that are being created here. If you want to look at what the table properties of the table, you click the particular table. In the graphic interface, you see some of the details. For example, you see the storage mode, it's import. So I'm importing the data from the SQL Server right into the model. So that's the storage method used. There are a few other details. We'll probably, in the interest of time, we'll just, visualization. I'll probably talk through this when we get to when we discuss visualization. So I'll park this for now. Let's move to transform data. So when you click on transform data, so now essentially what have you done now? We have queried the SQL store, we have loaded the data, but that's not enough. Now we need to now, based on the report requirements, we need to now transform the data. So for which, all right. So now, all the queries that were written are listed on your left. So you see all of them have an exclamation mark. That's because I've scrambled the connection string. It's not able to connect, which is why it's asking me to edit the credentials. So at the moment, you do not see the data fetched by this in the central pane, right? But then you will see all the steps that were written in here. So all the steps. Now, another easy way to look at all the steps would be to click the advanced editor. So when you click the advanced editor, it pulls all the steps for each of the queries in here. So when you're pretty proficient, you'll probably not even look at the applied steps. You will go straight to this advanced editor, and you will start tweaking the code here. So this is the M code that I was referencing. And in fact, pretty much you could do everything in here. So the transforms, what are the things that we generally do in terms of data cleanup? We have to remove rows. We can keep rows, remove rows. We can then transform by adding columns, removing columns, splitting columns based on delimiter. You can also do certain advanced functions like merging queries, appending queries, writing joins, left join, outer join, depending on your need. All of that can be accomplished in the combined section here. So it's actually pretty advanced, the menu-driven interface. Right? Then there are also aspects where you can after you're finished with modeling, you can run certain diagnostics. Those are listed. So and this is being covered in here, but there is a tool section in here. If you click that, it'll show the diagnostic where you can look at the query performance, etc. Then if you look at, once you've written the code, you write it once, you create this file, and then you refresh the data. So then Once that is done, when you refresh it, all the steps are applied. So it's kind of automating your transformation activities. For example, when you get a file for a month, you write this query based on this report, and then you refresh it. So the next day, and the next month, or the month later, or on a scheduled time, when the data comes in, you don't need to rewrite this. It just executes at when you either manually refresh or when you schedule a refresh. So you close and apply when you, at the moment I'm going to close this. So when you close and apply, you have now prepared the model. You've now cleaned the data. You've prepared the model. So you're done with this piece. The final piece is around visualization, right? So now you have got the model into your database, the PBIX file. But what do you do with that now? So now you need to, this is probably the most interesting piece, right? So now you've got the data, but you need to visualize this data. How do you turn this into actionable insights? That is where we have now entered the visualization phase of data analysis. Now, in the visualization phase, now they say a picture speaks 1,000 words, isn't it? So essentially, what are you doing? You're creating an image. You're creating an image from the data that helps the end user understand the information better. Everything can be illustrated in a table as well, but then some of the users may not find that as visually appealing so you probably have to represent that using an appropriate visual. So we call it a visual in Power BI. Now, there are quite a few standard visuals. In fact, there are 204 visuals already available. So you think of something, it should already be there. You want to do a comparison, time series, a spatial mapping, or a distribution box plot, or a correlation scatter plot. All of them are already available. I'll show that to you when we have the demonstration of the visualization pane. In fact, I've also linked the SQL BI in here. This is a very good resource for you to glance in when you have some time. Essentially, what they've done is they explain which resource is applicable for what scenario. It's very well done, and I frequently refer to the SQL BI source. Now, so as of now, we have only looked at descriptive analysis. Now, is that the only thing that you can do with Power BI? No, you can do some amount of inferential analysis also. So using the analytics pane. So there is one in the analytics pane. You access the analytics pane using that lens, the magnifying lens icon there. And then what can you do? So you can plot. You can forecast. Essentially, you can forecast using very basic regression models. It's not too advanced, but basic regression models. You can do time forecast analysis. You can plot averages, etc. So all of that. You can also do. You can also apply some of the generative AI models in here. So that is, you can ask you can ask it to provide its own analysis, quick analysis. So those kind of visuals can also be applied, but then you will need to add a few more things in your data set to ensure that it is analyzable, machine worthy and analyzable. There are a few other things you need to do. Grouping, binning data, all of that is for histogram related analysis. All of that can be done. Now, again, is that the only thing you can do? No, you can do much more. In fact, Power BI, the best thing about Power BI is the ability to build interactive reports. That is why it has become quite prevalent. Any user can just drill through. So you achieve that through drill through by layering the report. You remove the clutter in the dashboard. You just present the basic facts. If people want to drill that down further, you right click, drill through, you get the details, and then you right click and drill through, you get the details. So that way, you're removing the clutter from the dashboard. The dashboard is usable for novice users as well as for expert users. Then you can apply conditional formatting. This is our ever favorite, and most of the Excel users they love using conditional formatting. That is replicable in Power BI. You can also parameterize your variables. So let's say you want to play with what if scenarios in a finance forecast analysis. This becomes very useful, where you can add parameters for your variables, and the users can do what if analysis on the screen itself. So you see, a lot of what is technically complex can actually be achieved with just the menu driven interface of Power BI. so once you have done the report, you've done all the good work, you've created all the visualizations. Now what? So now you would want to share the data, right? You'd want to share that with the rest of the organization or with the rest of the world. So how do you do that? So that is where you enter into Power BI service, right? Now for utilizing this, you would need the appropriate license. Or at the basic, you need the Power BI Pro license. But there are other nuances also, like you could use the premium, the Power BI Pro premium per user and the premium per capacity. All of that gives you better and better features in terms of collaboration. Right. So essentially, what you're doing is in every Power BI license, regardless of the license, you get an online workspace. And what you can do is you can publish your report to an online workspace. And then you can control the settings of the workspace to control who in your organization is accessing the report, who cannot access the report, and to what extent, to what rows. You can define row level security to ensure that people are only accessing within the data, just rows relevant for them. So all of that can be established. You can also schedule. So what I've shown in here is how to schedule a report, which means it refreshes the data automatically. Either you can from a SQL server through an increment refresh, or from basic Excel sheets in your laptop or in your local drive through a data gateway. So that's how you would distribute the reports. Let me think. Yeah, so I have about 5 minutes, and then we'll open it up for Q&A. So let me give you a quick demonstration of the web application and the Power BI workspace. So all right, so this is so when you publish a report, you publish it to a web space, the workspace that I had mentioned. So essentially, there's a web application that So I'll show you how this is done. Essentially, we have not coded this web application at all, right? So all that we have done is we have published the report and then we have created a web application. All of these features are done by the Power BI service, which is why it becomes very helpful. So you see all the report that was there in Power BI desktop. It's listed in here in the left navigation. So it's menu driven, the left navigation in here. You don't have to code all of this. The Power BI service will do it for you. Then all that we did was we set these reports, and then these filters. So there's a live report. So in this, if you cross filter using these filters, all the numbers change, etc. So you can use these multiple filters together. That's how you set the visualizations. There are certain. So essentially, this center pane is where you have worked. The rest of it is Power BI service giving it to you for free, setting up the left navigation, setting up the top menu bar, all these options where you can view the report in full screen, all these reports where you can export this data automatically export this report into PDF, PowerPoint, all of that Power BI service does, and it just adds it onto your web application. Even this, where if let's say you want to export just this particular chart data into Excel, you can export the data. So all of these functions and functionalities are added by the Power BI service. Let me go back to the report, the workspace. So I had mentioned I'll walk you through the workspace. Now, so I had created a workspace in my personal account just to publish this for this demonstration purpose, which is why you see this 2025 leads at 2020. So from the Power BI desktop, when you hit publish, it'll ask you which workspace. And like I mentioned, every Power BI license comes with a workspace attached. So I published it to this particular workspace. You can see I did it last night. And then you can control the access here. So if in your tenant, if all in your organization, in your Microsoft tenant, there are people added, all of them will be listed in here. You can choose who can access this particular workspace. Then I had mentioned you can create a web application, right? So now you click on create app or update app, and this is all that you need to do. You choose what theme color these are, and then you choose the content. So that the content is what is published into the workspace. You just add the content in here. It's as simple as that. And then you define your audience as well. So for each report, you can say, I want it to be viewable only by a specific user. So you, again, all the users who are in your tenant will be listed in here. You choose a particular user and you click on update app. It gives you a URL. That URL is what you share with your, you distribute to your users. So it is as simple as that. Now let me go back and let me show you another thing about how to refresh. So in your semantic model, so when you right click this, right, or when you just click the ellipse icon, you will see a lot of options, one of which is settings. So you click on settings, uh, you'll have to define the gateway because it needs to fetch data. So you need to define a gateway through which it can fetch the data. As of now, I have not defined it, which is why the refresh is grayed out. But then if this is defined, refresh will be enabled, and then you can schedule a refresh here. So which means at that point of time on your scheduled date, Power BI service will initiate a request, and then it will fetch the data from your defined data source. And then your gate. So at that particular time, the only thing that you need to make sure is your gateway is on. That's it. Just your gateway is on. Then your Power BI desktop service and desktop will work together to fetch the data, refresh the data, and publish the data into Power BI service. So all of this, as you see, there's not much of code that you have written, but you're able to achieve most of what a traditional IT team would be doing. All of this is what we are calling the low code or the no code interface. Right? So I think so be 50 minutes. So I'll probably stop here, and then I'll stop sharing just to give an opportunity for participants to ask their questions.